Okay, so I've already explained in class that, this week we aren't having lectures in class like we usually do. That's why we're here on YouTube. And most of what we're going to be going over today is going to be a lot of review. I want to make sure that we have these ideas and these topics really, really well cemented in our heads. So, like I said, it's going to be some review. Of course, the section that we've been going over is decimals. And so, where do we get decimals? Well, there's a few places, like I've said in class, but a big place, and one that we usually think of when we're talking about decimals, is fractions. So, for instance, here, I have 2 over 5. Okay. Well, where do I get the decimal from this? Well, fractions all represent division. What we're really saying here is I have 2 divided by 5. So if I want to get a decimal out of this, I will go ahead and I will perform the division that this represents. Of course, like we've said before, the 5 here, our divisor, goes on the outside of our bracket. The 2 on top goes inside of our bracket. Okay, and then we say, can we divide this? So how many times will 5 go into 2? Well, it doesn't. It'll go 0 times. Okay, well, what we need to do now is add a decimal and a 0 here to keep on going. Adding a 0 after a decimal here doesn't change this number at all. We can add as many zeros as we want. 2.0 or even 2.00000 is the same thing as just 2. So I can add zeros after my decimal as much as I want. Now 5 goes into 20, well, 4 times. And it goes perfectly. So once we get our difference here, we have no remainder. Okay, so the decimal goes straight up from underneath our bracket to the top of our bracket. And as long as we have done our place values correctly up here, we get our correct decimal. So our decimal here is 0.4, or just what our quotient was. That's a little bit of a small 4. There we go. So again, our quotient, the thing on top of our bracket, is our answer. It's 0.4, and that's where we get our decimals from for our fractions. Okay, so let's try a few more of these things. Let me first clear off our board here. All right, so let's try another thing. Let's try an improper fraction. Let's say something like 7 over 2. Okay, this is an improper fraction. The number on top, our numerator, is larger than our number on bottom, our denominator, so it's improper. But we perform this just the same way that we did the previous example. So again, the number on bottom is going to go outside of our bracket. The number on top is going to go inside of our bracket. How many times will 2 go into 7? Well, 2 times 2 is 4, 2 times 3 is 6, and then past that, 2 times 4 is 8. So it's going to have to go in 3 times to get that 6. Okay. And we get our difference here by subtracting. We get 1. Now to continue going here, I have to add another place value. Just like I did with the 2 in the previous example, I should say, I have to add another place value here in order to keep making this go. So now, let's see, I can drop this 0 down. And 2 into 10, well, that'll go 5 times. And it goes perfectly. So here, we get no remainder. We bring our decimal place directly up out of our bracket. And again, as long as we have placed these numbers right here in the correct place values, we will get a decimal for our answer. 3.5. Yeah. Okay. So that makes sense because our larger number is on top, and that means that we will get a whole number out, since this is an improper fraction, and all improper fractions can be mixed numbers. So we get this whole number 3 out here, and then a decimal afterward. Okay. What if we want to go the other way, and we want to take a decimal and make it into its corresponding fraction? We can do that. So for instance, let's say we have a decimal of 0. 2. Okay, we're going to go with 2. 0.23. Okay. Well, this is actually quite simple. The way we change this from a decimal into a fraction is we move this decimal until we get a whole number. And we're going to need to count the number of times we need to move that decimal until we get a whole number. So let's see, I have to move it once and twice. And now there's nothing but a whole number. The whole number is 23. Okay, I'm going to put this as 23 over something, and that something is going to be a 1 with some zeros behind it. The number of zeros is the number of times that we moved our decimal. So because we moved our decimal 2 times, it's a 1 with 2 zeros behind it. And so our fraction is 23 over 100, or 23 hundredths. And that makes sense. If we were to read this decimal, using English, it would be 23 hundredths, because our last digit falls in the hundredths place. And you can think about it like that as well. So if I had 0.92, well, I can say that my last place falls in the hundredths place. I have a 92 here. So 92 hundredths. Pretty simple. All right, so let's try some more of these things. Let's get some whole numbers in the mix as well. I'll clear off our board. So let's say I have some whole numbers in here as well. So 2.59. Well, what I need to do is I need to recognize that I have not only a decimal, but also a whole number. This whole number is going to come out by itself. Okay, we're going to end up with a mixed number here. So we need to write down our whole number first. And then we're just going to think about the decimal here. So I can think about it either way. I can either say that this is 59 hundredths because my last place value lands in the hundredths place. Or I can think about it using the moving decimal. So 1, 2 times. It's 59 over 100. Either way you want to think about it, that's how you're going to do it. I've been talking about hundredths, so let's use one that's not in a hundredths place. Let's do something like 1.5692. Okay. Well, again, I have a whole number, so I need to write that whole number down first. And then I have a bunch of decimals back here. Okay, well, let's see. Can either move my decimal. 1, 2, 3, 4. And so I would have a 1 with 4 zeros behind it. And then 5692 on top. Or I can say that this is the tenths, hundredths, thousandths, 10,000ths place. And so this should be 10,000 down here. And yeah, it is. It's the same way, either way you want to do it. Like I've said in class plenty of times before, I don't care which method you use, how you think about these things, as long as you're able to get the correct answer using the method that you enjoy. Okay? So let's clear this off again and keep going. Another thing about what we've been doing so far with these is I haven't been simplifying them. So let's say that I have something like 4.32. Okay, well, 4.32, I can convert that pretty easily using the same methods that we have been. I write down my 4 first, and then I write down my 32 for my decimal points up here on top. Then above that, I know that I have hundredths. Okay, so we've gotten this 32 over 100, but we can simplify this. We can divide this by its greatest common factor. Now we know that at least they have 2 in common. Okay, so if nothing else, that's all you recognize, then go ahead and just factor the 2 out. Of course, this would become 16. And then let's see, 100 divided by 2 is 50. Well, these still have something that they can be divided by. 16 and 50. Let's see. Well, they can also be divided by 2. So again, if nothing else, just do 2. Okay, well, there we go. 8 and 25 don't share any more common factors, so our real common factor was 4 there. But like I said before, if you can't recognize anything else, just go for the one thing you know can divide both of them. As I said earlier, I don't care what methods you use as long as you're able to get the correct answer. Okay, so once you get these, it's a good practice to check and see if you can reduce them. Some questions will tell you specifically that you don't have to reduce them, and if it doesn't ask you to reduce them on the quiz, don't worry about it. But anytime in real life, you want to always reduce your fractions to simplest terms. Alright, so let's get into some actual math with these things. So like we said, we can add, subtract, multiply, and divide them. And I'll show you at least one example of each of those here. Okay, so if I want to add decimals, 1.32 plus 4.8. Okay. Anytime that we want to add or subtract decimals, we have to have those decimal points lined up. It's just like having a common denominator with fractions. You have to have the correct place values lined up to add together. I can't add tenths and hundredths. I can't add ones and tenths. They're not the right type of thing. So when I set this up, I'm going to set it up vertically. 1.32 plus 4 aligned with that ones place, point aligned with that decimal, 8 aligned with the tenths place. And I like to fill in any places that are empty, so I'm going to put a 0 there. Okay, and then it's just addition. No difference between this and regular addition. So 2 plus 0 is 2. 8 plus 11 is 1. We carry that 1 over. 1 plus 1 is 2, plus 4 is 6. And then our decimal drops straight down. There you go. That's it. Like I said, this addition is the exact same thing as any other addition problem you've ever done. The only difference here is that 1, you have to make sure you align your place values, and 2, you have to make sure that when you get your answer, you drop that decimal straight down into your answer. Okay, so let's see some subtraction as well. Let's say 6.49 minus 3.27. Okay. So, same thing. We need to line up our decimal places. So, 6.49 minus 3.27. Everything lines up. So now when I subtract, I do the exact same thing that I do in any other subtraction problem. 9 minus 7 is going to be 2. 4 minus 2 is going to be 2. 6 minus 3 is going to be 3. And that decimal just drops straight down. Okay, so nothing really new here. All right, let me move on to multiplication and division. So clear off our board again. When we multiply decimals, we don't have to worry about lining up any of our place values, because basically when we're multiplying decimals, we're just multiplying each number by the other place values. So if I have something like 4.9 times, let's use a whole number to start off with, 2. Like I said, when we write out our problem, we don't need to worry about lining up any place values. So 2 times 9, just like any other multiplication problem, we're going to get 18 there. Carry the 1 over. Okay, 2 times 4 is 8, plus the 1 is 9. Okay. And here is where trick comes in. We do not just drop down the decimal like we do in addition and subtraction. Instead, what we're going to do is we are going to count the number of decimal place values we have in our question. And that's the number of place values we will have in our answer. So I have one place value, one decimal place value in my question up here. 2 doesn't have any place values. So because I have one place value in my question, I need one place value in my answer for that decimal. Okay? Let's try one that isn't a whole number. So how about 4.35 times, let's make it a little bit more interesting, 1.33. Okay, I don't need to line up my decimal points. They're just going to happen to line up. So 4.35 and then 1.33. Okay. So now, just like I said, works just like any other multiplication problem. We just need to multiply each of these place values by each other place value. So 3 times 5 is going to give me 15. 3 times 3 is 9. Plus the 1 is 10. 3 times 4 is 12. Plus 1 is 13. Okay. Now, when I move on to this next place value, I need to show that by adding a 0 down here. Again, 3 times 5 is 15. 1's already there. 3 times 3 is 9, plus 1 is 10. It's already there. 3 times 4 is 12, plus the 1 is 13. Okay. One more. Okay, so move on to the next place value. I need to put zeros here. I moved on 2 place values, so I need to move 2 place values in. 1 times 5 is 5. 1 times 3 is 3. 1 times 4 is 4. And now we can add up all of these. So 5 plus 0 is 5. 5 plus 0 is 5. 3 plus 0 plus 5 is 8. 3 plus 3 is 6, plus 1 is 7. And then 1 plus 4 is 5. Please excuse my handwriting. This tablet's not exactly easy to write on. Okay, so now we have to ask ourselves, how many place values do we go into our answer? Well, I have 2 place values here and 2 place values here. So that's 4 decimal place values in total. So we need to go in 4 decimal place values in my answer, which means my decimal is going to end up there. Okay. All right. So that's the basics of multiplication. Let's do division now. So, when we divide decimals, it's basically nothing changing. There's only one little trick we have to remember. So let's try dividing a decimal by a whole number. Let's say 7.42 divided by, I don't know, 4. Why not? Okay, so my second number, my divisor, is going to go on the outside of my division bracket. The first number, my 7.42, is going to go on the inside, and now I just divide like I normally would. So let's see, 4 into 7, let's see, 2 is 8, so we're going to only be able to go one time. Our difference there is going to be 3. Okay, 4 into 34, well, we can go 8 times to get 32. Okay, we subtract, we get a 2 left over, drop down a 2. 4 into 22, let's see, 4 times 6 is 24, so 4 times 5 is what we're going to have to go with to get 20. And let's see, we get a 2 left over here. And we can continue to add zeros here to keep on getting place values. Now, I already have a decimal here, so don't add another decimal here. That wouldn't make any sense. So drop down this 0. 4 into 20 is another 5. Okay, and then this decimal, unlike multiplication, we can just bring it straight up into our answer. So I get 1.855. There's my answer. Okay, so when I'm dividing by a whole number, not a whole lot going on here. Let me clear off the board, though, and show you what happens when I divide by a decimal. So, make up another number. Let's say 4.34 divided by, and then let's say I have 0.02. Okay. So now that I have this decimal that I'm dividing by, if I set my normal division bracket up, 0.02 goes on the outside. 4.34 is going to go on the inside. And I don't know about you, but I do not know my multiples for 0.02 all that well. And so if I try to ask myself, well, how many times will 0.02 go into 4? I'm going to kind of sit there and I don't know. So what I do instead is I take this decimal that's right here in my 0.02, and I'm going to move it until I get a whole number. I have to move it twice to get a whole number 2. And that whole number 2 is much easier to find multiples for. Now, if I move this decimal on the outside, I have to move this decimal on the inside the same amount of times. So if I move this one twice, I have to move this one twice. It just so happens that this comes out to be another whole number on the inside. Okay, so let's see. 2 into 4. That's pretty easy. That's 2. get a remainder of 0. Drop down to 3. 2 into 3, it'll go once. We get 1 left over. Drop down our 4. 2 into 14, 7 times. It goes in perfectly. Okay? No remainder. So our answer is 217. The decimal's back here, which means we got a whole number for our answer. And you might be sitting there wondering, well, wait, I just divided. Shouldn't I end up with a smaller number when I divide? No. We're dividing by something very, very small, something smaller than 1. And when we divide by things that are smaller than 1, it actually ends up being more like multiplying things. Okay? Basically what we're saying here is we're dividing by a fraction. It's kind of like dividing by division. Sort of like when we say we have a double negative becomes positive. Sort of like here is division, so double division becomes multiplication. Just think about it like that. It's not exactly like that, but you can kind of think about it like that. So if you're dividing by something less than 1, you don't have a whole number, it's just less than 1, you're going to get a larger number out. Okay. So, that's division. Another thing that we've already gone over in class, but I want to go over again, is multiplying and dividing by powers of 10. So, what do I mean by powers of 10? Well, powers of 10 are any number that is a 1 with some zeros behind it. So 10 is a power of 10. 100, 1,000, 10,000, 100,000. All of these are what we call powers of 10. All you got to know is that it's 1 with some zeros behind it. And when we multiply by these things, or divide by them, it's really simple. All we're doing is we are moving the decimal around. So, let me clear this off real quick and show you what I mean. If I have something like, let's say, 24.28, and I want to multiply this by 100. So I'm multiplying it by a power of 10. What I do is I say I'm multiplying this by 100, so it should get bigger, and then these 2 zeros are how many times I'm going to move this decimal. So multiplying 24.28 by 100 is going to give me 2,428. Again, just however many zeros you have, that's how many times you move that decimal. If I have, let's say, 375.2713, and I multiply it by 1,000. Okay, well, that's 3 zeros. I'm multiplying, so it's going to increase in value. 1, 2, 3 zeros. And so my final is going to be 375,271.3, or 375,271.3. So multiplying by powers of 10, really simple. I'll clear off our board again. What about dividing by powers of 10? Same thing, just the other direction. So if I have 50.249 and I want to divide this by, let's say, 100. Again, count the number of zeros. That's the number of times you're going to move the decimal place. Now, we're dividing by 100. We're dividing by this big thing. So we should get something smaller. So we're actually going to move the decimal the other direction. So multiply one direction, divide the other direction. So when I move it 2 times, I get 50249, but the decimal is over here in front of the 5. So 0.50249. Okay? Are those the only powers of 10 out there? No. There are other powers of 10. So we're familiar with what I just told us about 1, 10, 100, 1,000, 10,000, and so on. But going the opposite direction, we have 0.1 for 1/10. We have 0.01 for 1/100th. 0.001 for 1/1000th. 0.0001 for 1/10,000th. Okay? So these powers of 10 can actually go both ways. Alright, well, what if I want to multiply something by one of these? Well, here's what I would suggest you do. This is the easier way of looking at it, because if you try to just move decimals, it gets kind of confusing. So if I have something like 2.45, and I want to multiply this by a power of 10, let's say 0.1, start easy. Here's what I would say you should do. Don't think of this decimal as a decimal. Think of it as a fraction. Convert that thing to a fraction first. So converted, this is 2.45 times, well, we say this is 1/10, so 1 over 10. Or, if we think about it farther, really this would be 2.45 over 10. Okay, well, we're dividing by 10. And like we said before, when we divide by 10, we're going to move that decimal once to the left. So this would become 0.245. I think that's much easier to look at when you're dealing with these decimal powers of 10. That's just my opinion, though. If you don't like that, don't have to do it. Okay, let me clear this off and come up with a new one. Let's see. Let's have 32.795. And I'm going to multiply this by 0.001. So 1/1000th. Okay. Again, I'd rather think about this as a fraction. That's just how my brain works. I like fractions. So this is 32.795 times. This is a fraction, like I said, is 1/1000th. So 1 over 1,000. Really, that is 32.795 over 1,000. And that's something we're more familiar with. We know that when we divide by 1,000, we're going to move that decimal 3 times to the left. So 1, 2, 3. We get 0.0327995. All right. So this is multiplying by these strange things. What about dividing by them? Okay, well, that's basically the same. If I come up with a number, let's have, what number have we? 8. 8.47. We haven't done that yet. Divided by 0.001. Again, 1/1000th. So again, I would rather think about this as a fraction. 8.47 divided by 1/1000. Now, if you remember, when we divide by a fraction, we need to flip this thing. So this is going to become 8.47 1,000. And when we flip this fraction, this is multiplication. Okay? So really, this is now multiplied by 1,000. And like we said before, if we're multiplying by a power of 10, we move our decimal place to the right. And we're going to move it 3 times, one for each 0. So 1, 2, 3. So this becomes 8,470. There you go. Just as simple as that. Okay, let me clear off our board. Okay, so the other thing is roots. And like I said in class, there's some roots that I want you to have memorized. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 roots that we should have memorized. So, square root of 1 is 1. Square root of 4 is 2. Square root of 3 is 9. Square root of 4, not square root of 4, square root of 16 is 4. Square root of 25 is 5. Square root of 36 is 6. Square root of 49 is 7. Square root of 64 is 8. Square root of 81 is 9. Square root of 100 is 10. Square root of 121 is 11. And square root of 144 is 12. Now, why is it useful to have these memorized? Well, these are our perfect roots. It's just a good idea to have these roots memorized. Are there more than this? Yeah, of course. I can keep going, there's numbers past 12, but these are the ones that you run into most often. And so for the purposes of our class, what this is going to help us to do is kind of understand where some of our imperfect roots land. So we know what all of these are, but what about the numbers in between these roots? So things like square root of 5. Well, a square root, like we've said before, is where we're saying what times itself is going to equal 5. Nothing. That's why it's not one of our perfect roots. But we can kind of estimate what it would be. We know that square root of 5 is between square root of 4 and square root of 9. So we can say that square root of 5 lands between here somewhere. So really it's somewhere between 2 and 3. We don't know quite where it is, but it's somewhere in there. Am I going to want you to know how to calculate these roots perfectly? No, not for this class. I just want you to be able to understand where it kind of is. Same thing if I had something like square root of 17. Well, that's going to be between square root of 16 and square root of 25, so 4 and 5? Somewhere between those two numbers. Okay. So that's the stuff that we have gone over so far. Now, where do we go from here? We're going to be going into statistics and probability. And statistics and probability has to do a lot with fractions and decimals. That's why we really needed to get those two things out of the way first. Okay, so one thing that I'm going to teach you right now from statistics and probability is something called a factorial. Okay, what do I mean by factorial? Well, it's this strange number that you've probably never seen before. Something like 4 factorial. It's got an exclamation point after it. So we say that this is 1 times 2 times 3 times 4. Okay, this, as we'll see when we get into statistics and probability, is going to help us a lot with calculating probability. Okay, so if I want to go ahead and do this, let's see. 1 times 2 is just 2. 2 times 3 is 6. 6 times 4 is 24. So 4 factorial is 24. All right. What about something like 6 factorial? Well, this one's going to get pretty big pretty quick. Again, it's 1 times 2 times 3 times 4 times 5 times 6. Like I said, these things get really big really fast. So let's try this one out. 1 times 2 is 2. 2 times 3 is 6. I'm just going to do it this way. So 6. 4 times 5 is 20. Let's see. 6 times 6 is going to give us 36 times 20. And 36 times 20. Let's see. 2 times 3 is 6. 7 is 720. Wow. That jumped up quite fast. Okay. If I asked you to calculate these things, I'm not going to go much higher than maybe about 6. I don't want you to have to be sitting there all day making these calculations. However, one thing that we are going to see is a lot of dividing these things. And you might be saying, well, that sounds really hard. Actually, it's probably way easier than just calculating those things by themselves. So, let's say that I have, let's use the ones we just used. 4 factorial over 6 factorial. Let's try again with that 6. There we go. So 4 factorial over 6 factorial. Well, like we said, 4 factorial is 1 times 2 times 3 times 4. And I'm going to use my dots to write that out. I'm tired of writing X's. Okay, 1 times 2 times 3 times 4. Okay. 6 factorial is the same thing. 1 times 2 times 3 times 4. But we also have times 5 times 6 here. Now, I said that this was much easier than just calculating the other ones by themselves. And it is. Because if we think about it, we're multiplying by 1 here, but we're dividing by 1 since it's on the bottom. So these ones cancel out. Well, same thing with the 2's. The 2's also cancel. 3's. And the 4's also cancel. Anything that's common between top and bottom, you can go ahead and cancel out. So all of this cancels. And so we're just left with 5 times 6 on the bottom. Well, that's really easy. 5 times 6 is 30. Then what do we have left on top? 1. As soon as we eliminate all of the numbers on either the top or the bottom, just 1 is left over there. So 4 factorial over 6 factorial is 1/30. That's it. Okay. And so that's where I'm going to leave off for now. I don't want to get too far into probability, but I do want us to understand how these factorials work before we get into them. Okay, so what is our password going to be for the quiz? I'm sure that's what we're all wondering. Okay, so our password for the quiz is going to be all lowercase d, e, c, I. Deci. That's the password for the quiz, just lowercase d, lowercase e, lowercase c, lowercase I. Okay, so good luck on that quiz, and I will see you next week.